He'll be fine on the mountain.
Hey everyone, what is happening? So today we're going to be talking a little bit about Lewis diagrams. Now last class we looked at ionic and covalent bonding, and we'll just do a quick reminder here that ionic bonds are a metal plus a nonmetal, and covalent bonds were a nonmetal and a nonmetal. Now remember that ionic bonds we drew them and we actually saw the electrons get borrowed or gained or lost or stolen. And with covalent bonds, we saw them be shared, the electrons be shared. Now, Bohr diagrams can be a little bit cumbersome. They take a little bit of time. And now what we're going to do is we're going to talk about Lewis diagrams or Lewis structures. So Lewis diagrams or dot drawings only show the valence electrons and use them to show bonding. All right, so let's compare a Bohr diagram and Lewis diagrams. So a Bohr diagram, well, let's start off with beryllium, and we're going to draw what it would look like on your periodic table. So we've got Be, we've got an atomic number of 4, we've got an atomic mass of 9, and we've got a charge of +2. All right, so let's draw a Bohr diagram of the atom. So this is going to be our Bohr diagram of the atom, and we would have beryllium in there, and we have 4 electrons, so we've got 2 in our first shell and 2 in our second shell. Now if we're going to draw the Lewis structure or Lewis diagram, it would just look like this. We'd have Be, and we wouldn't draw anything except the outer 2 electrons, and those are our valence electrons. Now what this is going to be a cation when it's turned into an ion. Notice we're dealing with an atom right now. So what happens, that +2 right there, that's going to give us our charge, and that tells us that that beryllium atom wants to lose 2 electrons so that it gets a positive charge. All right, let's try one more. We're going to try chlorine. And we've got chlorine with 17 protons, 17 electrons in the atom, and an atomic mass of 35.5 and a charge of negative when it is an ion. So we've got Cl, we've got 1, 2, and 3. And in our first shell we have 2 electrons. Our second shell we have 8. That's 10 altogether, and then we have another 7. We're going to put that into a Lewis diagram, and we're just going to draw our valence electrons. It streamlines the process, and it also allows us to see what it's going to look like when we're doing ionic compounds. You'll notice that it wants one more electron to be satisfied, and that's what that negative charge is going to be. When it's an ion, it wants one more electron to be balanced or have a full shell. Now what we're going to do is we're going to put these two together, and what we have is we have beryllium 2 plus, chlorine 1 minus. And you're going to remember this, we're going to swap and drop, and what we're going to get is we're going to get Cl or BeCl2. What does that mean? Well, it means that we have 2 Cl's for every beryllium. So the beryllium wants to give away 2 electrons, and the chlorine wants 1 electron, so that they can both be full. Now what this does is the beryllium is going to give 1 electron to one chlorine ion and 1 electron to another. So in the end we're going to get Cl with a minus, a beryllium in the middle with a 2 plus, and a Cl on the other end with another minus. If you added up all those charges, they would equal 0. Therefore, we know we've got a balanced compound. Next, let's try to make an ionic compound with potassium and fluorine. I'd like you to try that on your own, please. A Lewis structure as a potassium and fluorine compound. All right, let's turn the page. Next, we've got covalent compounds. Now remember that covalent compounds is a nonmetal and a nonmetal. So we're just looking at the right-hand side of our periodic table of elements. And so let's do, and we've got hydrogen that has a 1 and a +1 and an atomic mass of 1. And we've got chlorine, which has an atomic number of 17, a charge of -1, and an atomic mass of 35.5. Now, what we're going to do is if we draw the Lewis structure for both of these atoms, we're going to have H1, and our chlorine is going to have, just from before, we've got 7 electrons in the outer shell. And what you're going to see is that because nonmetal and nonmetal, or covalent bonding, they share an electron, that's going to come right down in there. Now when we draw a covalent bond in a Lewis structure, we're going to get H, and we put that when they bond, that bonding pair is drawn in a straight line, and then we're going to draw our non-bonding pairs as well. So what I'd like you to do is I'd like you to try one between hydrogen and fluorine. Give that one a shot, and we're going to try a bunch of this stuff in class. Have a good night.